Hi, I'm John Johnson with ProAmp Solutions. Welcome to my Ness Mess implementation. I have a customer with a beautiful Bassman amp. It's an AB165 Telltale right there. You can see some of the markings on the inside. I'm doing my initial visual inspection at this point and just early observations. The bottom of the faceplate is a little dented in here. The jewel lamp has been replaced with a green one. This is a little disappointing here. The power cord has been replaced, but the death cap is still wired and soldered in on both sides, so that was not removed. Most of this looks original. Obviously, this cap that's in the tone stack is not original, and then if you can see it here, the bias filtration cap has been replaced. I think one of the more disappointing things that I noticed on initial observation, get this up here where we can all get a good view of it. So I've disconnected these caps all to test their ESR and see if there's any leakage. I didn't expect any. Obviously, these are high-end Spragues. Not sure why this one wasn't replaced. I don't see any leakage evidence on it, but we'll test it. The disappointing thing is these two series resistors. These are the reservoir resistors for the capacitors for the power supply. These are 20 UF, and in series, that gives 10 UF of filtration. These are actually supposed to be 70 UF in series to give 35 UF of filtration. So whoever did this was well intended, but I don't think they understood the implications of what they were doing. Some generic, old, realistic tubes here. It looks kind of like a mishmash. I have tested these and documented their transconductance. So most of these, I think we're just going to retube this. The first thing I'm going to start on, this came in for Ness Mess mods. So the first thing I think I'm going to do on this one is revisit this. Obviously, I've got 520 UFs to choose from, and I only need 4. I'll replace these with 70 UFs, so I'll take the lowest ESR of these and keep the Spragues, and then we'll put the 70 UFs there. And I'm going to replace these voltage dropping resistors and then these voltage sharing resistors with new ones. As we move to thinking about how we're going to move forward, so basically, not all Ness messes were 100% identical, is my understanding. The gist of it is this half is an older rendition, actually, of a Bassman, a 6G6. And then this half here will become a Marshall JTM 45. So basically, from about here over, this will get depopulated. Obviously, we'll test all these caps, resistors for their tolerance, make sure they're okay. If they're not okay, we'll replace them. But as I go through it, the main change, this becomes that 6G6 version of the circuit. This is the JTM 45. And because this is a vintage chassis, I'm really adverse to drilling holes in the chassis. So I have a few ideas. I'm going to talk through them right now. Those are subject to change. But I think what I'm going to do, the JTM 45 has two channels on the front end going through a 12AX7. And I think what we're going to do is, because we want to add a mid control, I think I'm going to put the mid control here and use a double pole, double throw switch here to change the input on one to one channel or the other. So it'll still be 2 channels. We'll use this switch to change the channels. And I believe these will still be in phase between them. So I'm hoping we can run the inputs in parallel if we still desire to do that. So that's kind of my idea here on the JTM 45. Also, the JTM 45 and the 6G6 had 2 different negative feedback. settings. So I think I'm going to use the 6G6 did not have a bright switch. I'm going to use this switch location, I believe, to do 2 different feedback settings. I think that's how I'm going to handle that. Then on the back side here, we're going to replace the screen resistors, these grid stoppers. Along the back here, there'll be no purpose for the ground switch anymore, so that's obsolete. So we'll pick up a chassis hole here, and then I'm going to use a 3-way off standby on switch. So we'll pick up a hole here. So I think it's pretty intuitive. We'll use this hole for the impedance selector. So one of the things on the Ness mess is a different output transformer with multiple impedance selections to give you more versatility in the cabinets that you would hook this up to. So we're going to retain that aspect of the Ness mess. I'm going to put a really nice Mercury Magnetics Bassman output transformer in it with multiple impedance outputs. We'll put the impedance selector here, put the power switch here, and I'm going to put the master volume here. The only thing that leaves that I'm working on a solution for, that I haven't completely thought through how to do it, is some of the Ness messes had a mid control and they put it on the back. I've elected to put it up here. And rather than a master volume, they had an output power selection, but it basically achieves the same thing. So we're going to put a Frondelli style master volume on this in this location here. And the only thing I'm weighing is a presence control, and maybe where and how to put that. Not sure just yet. If I have to, I may move the fuse holder internal and use that hole. Not sure, but thinking through it, I'll work through this in stages and video the progress. But this is the initial visual inspection, the things that I have observed, and some that need to be tended to. So the first order of business will replace the power cord. We'll replace the power switch. We'll lose this switch here, which is irrelevant. We'll remove the death cap, and we'll take care of the power filtration. So I'll replace all of the filter caps, including this one, and we'll see, and I'll replace the tubes, and that'll kind of be the first phase, and we'll see if we can get this operational in its current state, and then we'll go from there. But basically the first step is addressing power, how that comes in, and retube it and see if we get it operational in its current state. I like doing things that are big projects like this in stages, so we can test operation along the way. The other thing we're going to do is on the AB165, this just has a fixed bias, fixed voltage. It's not adjustable. On this amp, you can adjust the dissipation of the power tubes and balance them for hum balance, but we're going to add an adjustable fixed bias and probably leave the balance in. So yeah, anyhow, that's so in terms of features, changes, mods to this amp, here we're going to add an adjustable fixed bias. This half is the 6G6. This half will become the JTM45. I'm going to add a mid control here. This will be the channel select for the JTM45. This switch will become a negative feedback selection switch with 2 choices. And then we're going to add a Mercury Magnetics output transformer with 4, 8, and 16. And we'll put an impedance selector switch here. We'll update this switch to the 3-way for off standby power. And then we'll put a Frondelli style master volume here. And I may put the presence control there, haven't decided. We'll put really nice screen resistors in it. We'll go through this along the way, all of the things that are done. First order of business is to replace those filtration caps and address the power supply. So I will tend to that. And then I'll rejoin in video. We'll show the completed work and walk through it. and then talk about the next stage, and we'll do another video segment on that next stage, get it operational, and then we'll move into, I'll probably do this output transformer second, and then we'll probably, yeah, I may do the bias along with the power work so that I can, when I retube it, set the dissipation on these and balance them. So kind of thinking through this a little bit as we document the video, but you get the gist of it and where this amp is headed and what we're going to be able to accomplish. So exciting project. This one's in pretty good condition. You know, I've seen better, I've seen worse, much worse actually. So we're going to get to it, and well, someone else has had their hands in this, but in this case, I usually don't like working after other people that are well-intended but don't understand the consequences of what they're doing. But this one's not too bad. We'll get through this without having to figure out what someone else has done. So excited about that, excited about this project, and I want to bring you guys along on the journey. I know there's kind of a lot of mystique about what the Ness Mess mods are. Like I said, when Billy Zoom did these, they weren't all 100% the same, so there is a little bit of variance in them. I've seen on the web pictures and gut shots of things that are slightly different between them, and I believe most of the time he just replaced the whole circuit board and started from scratch, which may actually be easier, but we're not going to do that on this one. I think I'm going to find the breaking point here, do this, remove that, do this 6G6 section first, get it working, and then move on to the JTM 45. I believe that's what I'm going to do. If I change my mind and decide to make a new turret board, well, that'll be part of the journey. Anyhow, looking forward to this. I'll get to it, and we'll rejoin when that first phase of work has been done. Excuse me, and go over that together. Okay, so I wanted to show this incremental step when I redo the filter caps in the Doghouse. Originally, when the original capacitors are in, they use the leads to make these jumpers across the back. So what I do is I leave enough of the old lead and I bend them over in each hole. So I am starting with the jumpers installed, but all of these holes are completely opened and cleaned, and I got a nice clean form factor to move forward with. So this is how I do it. Okay, I wanted to give you a shot of the finished Doghouse with the filtration capacitors in place and the new dropping resistors and voltage sharing resistors. So everything is in place, and you can see how nice and neat it looks by cleaning those holes out from scratch, and it just makes installation of the new components so much easier and much more stock looking. So that is the completed set of filtration caps in the Doghouse and the associated components. Okay, I wanted to show a progress report and what we've got done so far. So I've got all of the filter caps installed. The voltage drop resistors have been replaced with nice metal oxide 2 watters, and we've got the voltage sharing resistors in there. Did that with clean holes and was able to salvage the leads on what had been wired in before, so it looks really good. And as you can see, I decided to go ahead and install the new output transformer. So here's the Mercury Magnetics output transformer, and then I decided to kind of work backwards. So if you want to look at the back of the amp here, what I have done so far is I did decide to remove the fuse. So we're going to have a master volume and a presence control. Haven't decided which side to put them on, but we're going to do that without putting any new holes in the chassis. And I was able to get the 3-way switch in here. So this is off position, standby position, on position. And then we have the impedance selector. So this will be 4 ohms, 8 ohms, and 16 ohms. And you have dual jacks in parallel. So quite a few options in terms of what speaker combination you want to use and drive. So that's what this looks like. We'll flip it around to the back. And you've noticed here that I've really cleaned up a lot. So this is the back of the impedance selector here. This is the back of that 3-way switch. I've kind of cleaned all the wiring out of here. I've cleaned all of the holes on the power tube pins. And before I put the new grid stoppers in for the power tubes, I'm going to mount the screen resistors over the top. So I've removed all that, cleaned the holes. I'm kind of working backwards. As you can see, I've got one transformer lead left to connect here. I've got this side done. And then I did decide with removing the fuse, I'm going to use just an internal fuse holder, tuck it in over this way, well out of the way. Okay, I want to show a progress report on what I've been able to complete so far, kind of working from the filtration caps backwards. But I did want to show the inside here. As you can see, I've cleaned this whole area out. I've removed the grid leads because we're putting in a master volume control, which will involve those. And I've got the grid stopper resistors out because the screen resistors will go over the top. Just laying that out for the future when I get to that point. So I did install the Mercury Magnetics new output transformer, and we've got a 3-way selector switch installed in this location here. So we've got 4 ohms, the middle is 8 ohms, and then up will be 16 ohms. And then in this location, which was the old switch location, we have off, standby, and on, fully on in the 3-way position there. And then I did decide to take the fuse holder out. We're going to tuck it away down here in the bottom section very nicely. And so one of those will become master volume and one will become presence. We'll use the standard Fender knobs on the back of those two. So that's coming together. I'll turn it around so you can see a quick look at the finished filtration area. I'll put the camera up here so you can see it. Hopefully keep that in focus. So that is the new implementation of the filter resistors. If you can see, I was able to salvage the leads on the Spragues from the job that was done as we saw it when it came in, and make it look really neat. So we've got the new voltage dropping resistors and the new voltage sharing resistors. So that part is complete. And then let's see, there's a shot of the Mercury Magnetics output transformer. So basically I started working backwards. And then where I'm at this point, what will be next, we'll flip it back around. So as I'm thinking about it, what'll be next, I'm going to put the new power cord in. We'll be able to retain the convenience outlet, because this convenience outlet actually does have a wider blade for neutrals so that the polarity cannot be changed and it can always be correct. So we'll retain the convenience outlet. And then these two holes here that were from the fuse and the old ground switch, which is irrelevant now, we will have master volume and presence control. So what I think I'm going to do next is finish the power cord, convenience outlet. Obviously this will get wired into the fuse and then through the power switch. That will complete that section of power. I've got one plate lead to attach here. I've got the other one done from the transformer. Almost finished implementing the new transformer. So as I continue, I'm going to complete this part of the power section next. And then I'm going to move to the bias control. So you can see, let's see, I'll lower this a little bit. So down here where the bias filter cap was, it's been removed. So I think what I'm going to do is these two leads are connected here. I think I'm going to decouple that, and I'm going to put, as I come into the balance, what I'm going to do is I'm going to add like a what would be equivalent to a reservoir capacitor from the half wave rectification. Then I'm going to put a 10K resistor between here and here instead of that jumper, and I'm going to install a second cap, so it'll have like dual stage filtration and be a little cleaner. Then I'll run that filtered lead over here, and we'll reconfigure this here so that it will work for bias and balance both. Then as I move up here, I'm going to replace these plate resistors and of course test these coupling capacitors. But this section right in here is what I'm going to do next as a part of the power. And then after that, I'm going to move and put the master volume in because that'll involve those grid resistors here. Then I can complete the screen resistors, and then we'll just continue working backwards. So at that point, I'll be able to power it up. We'll put it on the current limiter and so forth. And we'll test the operation of the bias voltage without tubes in it, check our range, make sure that makes sense and is reasonable, make any adjustments necessary. And then, yeah, we'll work on the long tail pair phase inverter, and we'll just work our way backwards. And I have implemented this three-way impedance switch. This is the feedback. So we're going to attach this to the 4 ohm connection like it was originally. I was looking at the tail resistors here and just checking that out. So when I re-implement this, I'm going to use a shielded cable for the balance of this, because it's going to end up traveling over to the switch and then back to the board. So I'll use a shielded cable for that. And then we'll have 2 different feedback settings, one for the JTM 45 and one for the 6G6. So you can switch between those 2. So that's really, I think, what I have next in store. So at our next update, we'll have the AC power completed. And I'll have the master volume in and the bias circuit completed. And I think what we'll do at that point is do just a power on test without tubes, so that I can test the bias voltage range, make sure that makes sense, and that we don't have any faux pas in my work so far. So that's where we're at right now. Wanted to be complete and thorough in updating you on what's been done. The green lead is 4 ohms, the yellow lead is 8 ohms, and the gray lead is 16 ohms. Pretty much a standard, but not always. For Fender, green 4, yellow 8. So this is a really high quality 3-way switch that we have implemented here. So basically, I don't mess around. We use high quality components. I want my customers to be raving fans, and we don't cheap out on anything. You can see I've cleaned up some of this lead dress, and it really helped cleaning out this section here and opening up the holes for the power tube to make that work go smoothly and much more rapidly. And then, yeah, we'll work our way back on the board, and we'll get this 6G6 section going and fired up and working with multiple impedances and get it all biased up at that level. And then once we get the 6G6 completed, we'll be on to the JTM 45. Just a quick review on the front side, what we're going to end up doing here. So this switch here is going to be replaced with a double throw, double pole switch, so we can implement that feedback. And then up on the top here, I've got a mini knob that looks identical to the Fenders that we're going to put here where the second input is. And then this switch here will change between the JTM 45 inputs here, and that'll allow me to put the mid control right in there. So that's the plan, and we're making good progress. Happy with the work so far, and we'll come back and rejoin once I've completed this next stage, and we'll test the bias voltage range together. Thanks. Okay, so I wanted to show you Zoom out here a little bit. Focus. So what I wanted to show you now is I've got the new power cord installed, the fuse internal and heat shrinked off, cable managed, and my calculations for the circuit couldn't have been any closer, so that saved time. But let me show you what our range is. So we're minus 56, and we can take this down to, I believe, about 34 or 35. Yep, there we are. So beautiful range. And what that did is it opened up an opportunity that I'd like to take advantage of. So on the power tubes, I have cleared all of the holes out. You can see all I have is the plate connections in right now and the ground connections to pin 1. But I think what I'm going to do, I'm going to tie 1 and 8 together so that this amp could run EL34s and 6L6s, because I think this bias range will support that nicely. So another added benefit or feature of this amp will be that you can run EL34s or 6L6s in it. Beautiful bias range, real happy with it. So I've got it roughed in right now. I'm going to go ahead and finish this part off, and the bias circuit will be done and proven. And I do have my double filtration. Can't really see that real. There it is. So I've got a 470 ohm 3-watt wire wound resistor, the diode, and then so this first cap here would be your reservoir cap. Then I've got a 2.2K resistor and a second filtration stage. So actually, let me put my meter on AC and we can see our AC ripple. So we are at about 5 millivolts, 4 millivolts of ripple. So you can see that the filtration is just fantastic. So no noise will come in off the grids from the bias. Couldn't be happier with the range and where we ended up there. So this is that stage. I'll come back in a few minutes and go over everything I've done to get to this step. Just wanted to show the bias range, and I'll go over the value of each of these resistors. I'll also move the balance control for you. So I've got this on one side, but you can see how the balance control is subtle. It will vary from side to side, and from one side to the other, max swing, so 54.5 to 57.5. So you got about 3 volts of swing you can do, which is more than enough, but also nice and subtle. So again, couldn't be happier. So we can balance. So if we happen to have tubes that weren't balanced, we have a way to balance them, and enough bias range for EL34s or 6L6s. So very pleased, and we will move on to the next step. I'll come back in a few minutes and go over what's been done up to this point and next steps. Thanks. Okay, I want to talk through where I'm at on these next steps, getting ready to implement the master volume, and I wanted to double check the bias and balance circuit. So just to cover that just real briefly again and tell you what the components are. This is the balance pot that was already in the AB165. I've just cleaned it, done a re-implementation. So we do have a bias tap off of the transformer. Comes here, and it gives about minus 63 volts-ish, plus or minus. We're coming through a 3-watt wire wound 470 ohm resistor, and we've got our half-wave rectification diode there. So this would be the reservoir capacitor for that half-wave circuit. Then I've got a 2.2K RC filter with another 50 UF cap to ground. So that's that's basically the filtered bias voltage. You get about minus 63 here. That comes over here. So as you can see, I've cleaned up a lot. There was a lot of stuff in here, and I took the terminal strip out. So what I did here, I removed the jumper here. So this lead here is the choke return, and that's the filtration lead for the screen. So the screen resistors for the power supply, that comes here and connects up through there. So I removed the jumper between here and here, and that way I could feed the bias in here. And when I centered the balance pot here, that gave me a nice way to hook this up. So these are two 10K resistors to each side of the balance pot. Then I've got an 8.2K resistor coming into the leg of the 50K bias pot, and those other two legs of the bias pot, of course, are grounded there. You'll notice one thing I've added, and this is with regard to the master volume, which I want to talk about a little bit. I know the Frondelli master volume is very popular, and you don't need to use the safety resistors in case the wipers lose contact in the pot, and you would lose bias voltage. So couple things to note here. One is if something ever happened to this and it lost its connectivity here in this section, this would go to this is its ground connection here. So it would go to its greatest negative voltage, which would be basically a safety feature. Then what I'm going to implement here is a Lamar or a Trainwreck Type 2 master volume, and I will explain why I'm choosing that over the Frondelli. The way the Frondelli works is it takes these are two analog 250K dual pots, and it takes the place of the resistors between the plate and what was ground or the old bias points with the balance. So a Frondelli works by taking that 250K, and as you turn the pot down, you're basically loading the phase inverter. And because a long tail pair phase inverter can drive a relatively low impedance, you end up with very little control on the bottom end of the master volume. It just kind of jumps into some volume, and I just don't think it works that well, actually. It's pretty disappointing. Sure, it's a master volume, but down on the bottom end, I mean, you just got to really crack it to be effective. So what we're going to do, we're going to use the Lamar or Trainwreck Type 2, and I am going to use the 1.8 meg safety resistors across there. But what this does is it maintains the 220K plate load at all times, and then just sends the signal how elevated you are from ground to the grids of the power tubes, which in this case, in this implementation with this long tail pair, is going to give me much better sweep on the master volume. The other thing that you will notice that I have added, I think this thing's starting to look like the Starship Enterprise a little bit, but I have added a 10 UF 160 volt cap from the bias feed point to ground on each side. The reason is where I come into the low side of my master volume, without that capacitor there, this is elevated by 10K. And so this would never actually turn all the way off. It would be horrible. So what this does is this gives the AC a path to ground at this point. So from an AC perspective, coming from the low pin to here, it is fully bypassed to ground. So that would completely silence the amp. Without these here, that would not be effective. You'd be elevated by these two 10K resistors. So just a little explanation about that, why I'm not going to use the Frondelli, and I am going to put a Lamar or Trainwreck Type 2 master volume in here. Just a couple things to note in terms of lead dress. I'll put this up here just a little bit. One of the things I've done, I've tie wrapped this and tidied it up. Whenever you basically cross points where noise can be induced, you'll notice I've got the 6.3 volt line here. You want to cross paths at a 90 degree. That minimizes noise coupling. Just a minor detail, but it can make a difference, sometimes more than others. You'll see I have the fuse shrunk wrap protected there and tucked nicely away here. And all of this is cable managed. And what I'm going to do is from the center pin on each side of this dual pot, I'm going to come down with the 1.5K grid stopper resistor to the power tubes, and I'm just going to bring that right in. I'm going to heat shrink the 1.5K resistor on the end of that lead and put it right on the end there rather than coming across, because of the sweetness of our bias voltage range, about 56.5 to 33.5 volts. We could run EL34 or 6L6s here. So my very next step is I'm going to couple pins 1 and 8 on each of the power tube grids, which is required for an EL34, but that is typically how the 1.5K grid stopper is run. But we're not going to do that. We're going to give the versatility. We're going to couple 1 and 8. And then I've got these two spots here prepared. I'm going to use shielded cable from the junction here to the low point on each side. So a shielded cable is going to connect here and come up here. Then we'll have the 1.8 meg safety resistor coming down to the center pin, and from the center pin we'll come out with the 1.5K grid stopper to the grids of the power tube. Then what I'm thinking about doing right here, these are the coupling capacitors coming out of the phase inverter that will terminate here. I think I'm going to bring another ground from the brass plate up through this hole right here and loop it, because I want to run a shielded cable from here to the high side and here to the high side on the master volume. That way we'll have shielded cable from the output and then shielded cable from the ground side, and then we'll just have the short run for the signal level coming in. So that'll be the next step of the implementation. I'll go ahead and put the 82K 1 watt resistor here and 100K 1 watt resistor there, and we'll put our coupling caps in, and then we'll have this completely implemented with the master volume. The new bias and balance control should be fully functional. I've done some voltage tests. Our high voltage basically at the reservoir unloaded is 463 volts. And then we'll look down the progression of the voltages once we get loads across the amp. So I think with the master volume implemented, this section of the amp, I think what I may do too, right after the master volume, I think I'm going to implement the switch here and go ahead and get the negative feedback hooked up. And I've decided on the negative feedback, I've done the math and done the conversion factors between the JTM45 and this 6G6B. I'm going to use the 8 ohm tap, kind of meet in the middle. So the JTM45 used the 16 ohm tap and a 27K resistor. And so of course the Fender uses the 4 ohm with a 47 or 56K resistor. So I've done the math and the conversions, and what we're going to do, we're going to use the 8K tap, and we're either going to have an 18K resistor or an 82K resistor. So quite dramatic. One will give a lot more feedback than the other, but that would be the equivalent of the JTM45 and the 6G6. So you'll have two pretty versatile feedback selections. So that should be pretty nice because it'll make it'll be meaningful, be a noticeable difference in feedback to taste. And then with that, I'll probably, so this is the master volume in the hole right here. I'm going to put the presence control. So from the back side, you can see we've not added any holes. By moving the fuse inside, we'll have another Fender control here for presence. So that's how we're going to gain all the functionality that I'm working towards. So yeah, we'll come back and rejoin. I'm going to get the master volume hooked up. I'll wire in the feedback here. And then I'll probably go ahead and work on the long tail pair, making a couple minor adjustments there. And of course, that's where the feedback and the presence control are going to come into play. So I may do all that in one pass, master volume, then move on, get the dual negative feedback selector switch in, and then work. Maybe I'll stop there, we'll cover it, and then we'll do the long tail pair how we're gonna configure it, and go ahead and put the presence control in. We're gonna use shielded wire again from the speaker output over to the switch, and then from the switch to the board. And then of course we'll use shielded wire for the presence control where it comes in below the tail here too. So yeah, I don't want to bite off too much. We'll do the master volume and the negative feedback here. And so this will all be in place and functional without presence. And then I'll probably just run the amp this way, this channel, make sure everything's working, functioning, test the master volume. The master volume is a global control, so it'll affect both channels. The presence is a global control, will affect both channels. And the feedback selection is a global control and will affect both channels. All other controls will be channel specific. So that's where we're at. And like I said, we'll get that done. Then we'll rejoin, take a stab at the long tail pair, talk through that, and implement the presence control. Then basically with the long tail pair done and the power section done, really all I have to do is just work this right here to complete the 6G6 side. And I'm going to also use shielded cable in place of these two wires here. The signal cable into the grid, and then I think the connection from the volume on the next grid. So yeah, these two will be shielded. So I'm definitely going to add some shielded cables in here. I really like quiet amps. We're also going to replace these 68K input resistors on both sides of the amp and put 1 watts in there, metal film. That will also contribute to some noise reduction. And then all of the plate resistors, I'm going to put 1 watt metal films in, and we'll see how the rest of these go. So that's where we're at, the why on the master volume, and I'll get this next wave of work completed, and we'll regroup, we'll rejoin. Thanks. Okay, I'm ready to show you what I've accomplished, the next step that we talked about earlier. So what I have completed is the master volume control and the coupling and plate resistors here. These are the plate resistors for the phase inverter. These are the coupling caps to the plates on the power tubes. So I've gone over this in the last video. So what I did do is I added the 18 gauge cable here, put a loop there for the ground on these shielded cables. So these two go to the bottom 2 pins there. And then I am cognizant that the presence resistor needs a little space here. So I put the 1.8 meg resistors on the inside there. And then each side has its own bias supply, and that's all hooked up. And then you see I ran my grid connections down, and I heat shrunk the grid stopper on each side. So this is complete, and I have done some testing. So what I wanted to make sure of is in the first position on the power switch that I had no high voltage present at the plates, and I do not, but there is 460 volts at the reservoir and where the diodes come together here, about 460 volts unloaded. And then if I turn the power all the way on, then I have about 455 volts present at the screens unloaded, and just maybe a volt more on the plates. So the power switch is working correctly, and I do have voltage at each screen and at each plate. And on the bias voltage, I made sure that the negative voltage was balanced between the two power tubes, and that I had negative bias voltage present on both locations. So I've got about, at its maximum negative, about negative 55.5 volts on both sides, currently balanced. And then if I move the bias and make it hotter, I can get to about 33.5 volts. And so you can see I did install the 5-watt wire wound screen resistors here, and I did connect pins 1 and 8 on the two power tubes. So now you have the versatility to run the EL34s or the 6L6s, and you can see my my lead dress. Kind of tedious work in here, but this is all done. And so for the next step, what I'm going to do, obviously this is a global control, the presence is a global control, the feedback will be a global control. I think it's a good time to do the phase inverter and the tail, because that's where the feedback comes in and that's where the presence control connects. So what I think I'm going to do, probably remove these knobs, clean up the face here, get the old switch out, put the new switch in, and then I'm going to do the phase inverter with the variable negative feedback and the presence control. We'll do our shielded cable and get that all hooked up. And then basically all I'll have left to do is just make this the 6G6 with the correct pots here, and we'll use shielded cable on the inputs as we talked about earlier. So one step at a time, a little tedious and time consuming, but you can see the progress here. Next step, phase inverter. With the presence control and the feedback control. My goal here is to get the amp basically with this half of the AB165 in a working state, and I'll be able to test basically all of the added functionality, the multiple impedances for the output. We know the power switch, it's already tested. We'll be able to test the master volume, be able to test the presence, be able to test the switchable negative feedback, and of course the response with the volume and tone controls. Once that's done, then I'll just make this the 6G6, and then we move on to the JTM45. But all the global controls and mods will be done, and I could basically do this part in my sleep. So moving along, I think this is kind of the next most tedious and difficult, but we'll get this done. We'll get this tail section done. Oh, by the way, these blue Astrons that were there, I would have used the original, but the ESR on them was almost a K, really bad. So they were leaking horrendously. So replace those with the Sprague 716 series polypropylenes, which I really like. And again, as we go through the top, I will put 1-watt plate resistors in all the locations, and we'll see how it goes. So just a real quick review: phase inverter, the presence, variable negative feedback will be the next step, and then once that's completed, we'll come back and document that. So in terms of components, these are both 22 Nan. That resistor is 100K, that's 82K. This is a dual gang 250K pot. These are the 1.8 meg safety resistors. I've checked this in parallel with the 1.8K, and it's about 222. So really close to the original value of the resistors it replaces here. Couldn't be happier with that. One thing of note with the Lamar, if you move the control all the way to the least volume or off, it does impact the bias voltage very negligibly, but it does get just a tick more negative. So when we do bias the amp, we're going to want to do that with the master volume full on at 10 and set our maximum dissipation at the plates. And then as you turn the volume down, it would just ever so slightly go a little more negative, which is fine. So that's a summary of where we're at, and we'll move on to next steps and rejoin. Thanks. Okay, I'll document the progress. As you can see, got a little farther along than I had anticipated. Kind of got on a roll since the last time we reviewed the work. So originally I was going to get the phase inverter section done and incorporate the negative feedback and the presence control. As you can see, basically I went and finished the whole 6G6 side. There were some implications with underboard wires and things, and once I had a thought process, I just kind of continued on and rolled through it. So what we'll talk about today is what has been done and some of the points that maybe aren't real obvious just looking at it. So I completed the phase inverter section. Everything is 100% the value of a 6G6B with just the following exceptions. So in the phase inverter, the resistor here, this is 680 ohms, and this resistor is 8.2K, and then it comes into the 4.7K tail. So that resistor is different, and this resistor is different. And then the input coupling cap is 10 nanofarads. So the reason for those differences is between the JTM45 and the 6G6, just through experience and doing some calculations, I basically landed right in the middle. So the 6G6 and the JTM45, their disparity here, again, basically in terms of those three components, I met in the middle. Everything else in terms of the signal path is 100%, including the treble control. And shout out to Mojo Tone for carrying the 350K capacitor with the 70K tap. So that is done. And then I just rolled on through and completed the circuit. Some things to note that I did to accommodate the wiring and the differences in the Bassman channels. We talked about earlier, I eliminated that jumper for the bias. Then I left, there's a ground connection that goes between here and here, that link. I left it in place, but ended up not using this. I was thinking originally I'd put the 4.7K resistor here and ground it there and use that, but I decided against that and went ahead and put it on the presence pot there. So of note though, there was a link. So I've changed how the power distribution comes in, mostly to get this working for now. I may actually change this in the end, but for now, I eliminated this connection here, and I brought the power in, and this is the 220K there to pin 6, and this is the 100K to pin 1 over here. So as we look at this part of the circuit, one of the things that I did as we move across here, underneath my phase inverter input coupling cap, there is an eyelet right there. There was a jumper between this eyelet and this eyelet. I removed that because I was originally thinking I'd put the coupling cap here in the 470K channel, and this channel comes in through a 470K there. Anyways, I decided to do it this way and use this hole for mixing the two channels. So that really doesn't need to be done if you wire it this way, and this ground connection between these two is inconsequential. What was consequential was there is a underboard jumper between this location right here and count down 4 and right here. I removed that because there's no longer any power correlations between what was hooked up earlier in this amp with the other channel. And then the blue power lead coming in here, I brought over here, and the yellow power lead is here. And as I'm thinking about the JTM 45 for the coupling, there's an underboard lead from here that comes up to this point, and then from this point down to let's see, believe it, yeah, this point. So I think I have this circuit working. So I've tested the amp. The sweep on the master volume is just gorgeous. Love the travel and how it responds. The treble control is fairly acute, very pronounced, very good range on the treble. Bass is a little more subtle, certainly works just like it should. And of course the volume is wonderful because I can dime the volume and then taper it back and not really lose any tonal quality with the master volume. Presence control is subtle. If you understand the amps, the presence control, it affects the high frequencies passed on the negative feedback. So what I did here, you can see that I've used shielded cable for most of these runs. On the input, I use shielded cable. On the volume return to that grid, I use shielded cable. So a lot of this work is tedious, lead dress, heat shrink, taking all of that into consideration. But I'm very pleased because I brought the circuit up, of course, on the current limiter and made sure there were, I did some very thorough testing along the way, and very pleased to report it just works beautifully. The negative feedback that is global works. The presence control that's global works. The master volume control that's global works. And the three-way impedance switch works. I put different loads on it, responded correctly. So really good shape, and the 6G6 and all of those global mods are done, functional, and working. So I'm going to finish the JTM 45 section next, and I do think what I'm going to do, there'll be some so the final tuning, I've left the cap on the other side off of the Doghouse. So once I get the JTM section in and I have all of the tubes loaded and the voltages settle in, I'm going to check my voltages through the plate resistors on the respective halves, and I may make a final adjustment on the voltage drop resistors through the filtration stages to get the voltages exactly where they need to be for the 6G6 side and the JTM 45 side, but that's to be determined. Right now it's fairly simple and straightforward because all the voltages that come in from the reservoir to the screen to the phase inverter are correct. So this right here is the only one of consequence, and it's just run right here through to the blue lead and jumpered over. So for right now, my mixing comes in here through the 470K, and then under the board there's a connection between here and there, and I'm gonna take out those underwire connections, and because I'm gonna need more of these holes than are accessible right now, and I may add a couple of eyelets to make the JTM implementation a little easier. But basically this is complete. The only difference being on final tuning, I may make some adjustments to
the voltage level coming to the plates on these preamp tubes as we get a little farther along. So again, all component values are exactly 6G6 with those 3 exceptions, and those are kind of a middle ground between the JTM45 and the 6G6. Presence control is implemented with the 25K pot, the 100 nanofarad cap to ground, and the 4.7 resistor to ground, shielded cable into the point where the negative feedback comes in right here. So that's the underboard changes, things that might be gotchas if you're not aware of them. And of course, if you are doing this to a different version of the Bassman, you'd have to be cognizant of underboard connections as you're going through it and kind of mapping your layout. I think this laid out just beautifully, and my intention is to keep that same methodology down on the JTM45 implementation. So let's talk about the JTM45 implementation real quick. We're going to put the mid control here down at the bottom where the number 2 input is. And lower the camera here so we can kind of see this and talk about it. So this is where the mid control is going to go. This is going to be a double pole, double throw switch. So you'll be able to switch between the bright channel and the normal channel on the JTM45. And then the volume control is going to switch to a dual gang 1 meg pot because each channel needs its own volume control. So we'll have a single volume control which will sweep 2 pots. One will be, and what this switch will do is it'll mute the channel that's not used. We'll ground the input. So relatively straightforward. So my next step is going to be to remove the underboard wire from here to here and there on down to free up the use of some holes. And I may just take this power connection off and figure out how I'm going to add it later. And then these 3 spots are where the 3 tone leads come in. And I'm going to leave them there for now. We'll figure out the best way to tie into that on the JTM45. If I was doing this all over again, or doing 50 of them, I'd make a new circuit board with eyelets or turrets specifically designed just to do this. But in this case, it's pretty much a one-off for me on this project. And I like the ideation of going through the board as it is and figuring out how to leverage it and use it for this implementation. And I think it's actually going to be fine. I did clean the fiberboard thoroughly. It was kind of mildewy. You'll notice it's very clean right now. I cleaned all of the old holes. I cleaned it down with a toothbrush and some cleaner. So that turned out really nice. So basically, it's just a go-forward build with open holes. I am going to have to change the input. It'll actually simplify. So I'm going to come in here with a single 33K resistor that'll actually go to this switch. So I'm going to put that 33K grid stopper resistor just between the switch and this lug. And then we'll use shielded cable to come to both inputs off of the switch. So pretty straightforward. So my next step to kind of make a clean build forward is going to be these pot values. I know one of them changes. I got to put the dual gang pot in here. And so I'm going to take this out, put the switch in, get the correct pots in, clean this face panel and the knobs, get this all ready for the forward build. Then I'm going to think through the layout, and we'll get the JTM45 section completed and then come back. Of course, the JTM45 section will be completely stock. The only changes will be the input. I'm going to switch it instead of having dedicated jacks. I'm going to switch between the 2 channels with this switch. So that's a change, but it doesn't affect functionality or one or the other. And then I'm going to come out of the treble control to mix in with another 470K resistor. So yeah, this is relatively straightforward. We're going to make it the exact JTM45 blues breaker circuit, regular and bright channels with the switch, To implement that, we're going to use the dual gang volume pot and the switch. The mid control will go here. And yeah, so I'm very excited. I put, for testing, I took old tubes out of a bucket, rough biased them in, and did a quick sound check, made sure everything responded. And then I looked at it on the scope with my load, because I can adjust all my loads to match these impedances. Look at the signal and change my signal generation from 100 hertz up to 1K. See how the mid scoop looks, and it's beautiful. I'm really impressed with the response of the master volume control. It worked out just like I had envisioned. That doesn't always happen, but as my daddy said, measure twice, cut once. So I have done a lot of measuring, calculating, planning on this implementation. And as I got through here, I kind of got on a roll. As the great legendary coach said, be quick, but don't hurry. So I was kind of on a roll, and I just kind of moved through it. It was going well. I had open holes, and my thought process on what needed to go on relative to what was under the board and how everything was going to connect was just flowing. So I moved on through it. And I look forward to wrapping up this section and concluding the video. And we'll move through this, and I'm looking forward to rejoining and showing you the completed JTM 45 section. Okay, great news. I got the JTM 45 section completed. It went smooth as silk. Didn't even have to add eyelets, just had to think it through and make a little bit more creative layout here. And from the last video, the only thing I did do that helped was I did remove that link from here that came up here and then down this way. So I removed those two to clear the way. And as it turns out, the 6G6 needs 355 volts here, and the JTM needs 310 volts here. So yellow is the last leg, or the lowest. So this worked out. I was able to bring pin 6 of this down to one location that the yellow lead tied right into, and then I just created a jumper from the blue lead over here. So the power supply worked out great. Everything is stock JTM 45 values through and through. I've got the 100 picofarad bright cap on, the mid control. Everything responds and works correctly. So the amp is just about finished. So what I'm going to do now is I'm going to put the brand new tubes in it. This customer requested Telefunken 6L6 GCs. So we're going to put the brand new power tubes in it. We're going to bias the power tubes and put the new preamp tubes in it. And then once the power tubes are biased exactly where I want them, then I'm going to come back and I'm going to check the voltage here, and I'm going to check the voltage here. And because we know the resistance of each one of those voltage dropping resistors back on the Doghouse, once I know the voltage here and the voltage drop across those resistors, I can calculate the current flow across those resistors and make an adjusting value if I need and dial it right in. So that really is the last step. Again, no surprises here. It went smooth as silk. I think from the last video I talked about, I did join this in with a 470K. So this is the mixing point here. This comes off of the treble control. So yeah, and I did use shielded cables on both sides of the input. So I have the input down here, and then this switch, if you are in the down position, it is the normal channel and it grounds the bright channel. If you go up, it is the bright channel and it grounds the input of the normal channel. Works flawlessly, doesn't pop or make any obnoxious noise. So both the normal and bright are working with this switch, and all of the controls respond as expected. So very, very pleased. So at this point, I'm going to tube it up go through that exercise of biasing the brand new power tubes, and then I'll come back and share if there's any value change. Right now in the Doghouse, the dropping resistors are all the stock 6G6 values. If any of that needs to change, I'll let you know what I ended up doing if I do make a change. So that's really the last step. And I'm thrilled about how it's come together on behalf of this customer. And we'll follow up with that last little segment and just talk through the finished product. Thank you. Okay. Well, this amp is complete. This is the AB 165 conversion to Ness Mess. And boy, has it been fun and a little long in the coming. And I wanted to do a final review and go over some of the final tunings and tweaks and a couple of adjustments that I made. So I did end up tuning the voltage drop resistors inside the Doghouse. So it is AB165. It's got the 270 UF capacitors with the 220K voltage sharing resistors. Then the choke and a 20 UF. Then it's got the 3 stages. The first one has a 1K. The next one has a 10K. And the last one has a 10K. And that worked out just beautifully. So I've got the plates biased at 60% right now. And I was looking for 355 here in accordance with the 6G6 schematic, and I've got 354. And here for the JTM side, let's see, I was looking for 310, and I've got about 306. So that couldn't have come out closer or better. Super happy with that. So that was the final adjustment in terms of the voltage drop resistors and how that ended up. Actually, slightly better filtration with the last two 10 and 10. So that was beautiful. I did notice as I increased volume, I got motorboating, and I had made a silly mistake. I had swapped the brown. I initially had the blue transformer lead on the right and the brown on the left, and I was actually sending positive feedback to the amp. And while I thought it was working, as I turned it up, I got motorboating and some oscillation, and I knew right away, oh boy, you made a mistake. So fortunately, I found it quickly. So the blue lead goes on the left, and the brown lead goes on the right to give you negative feedback. And then I decided on the switch to actually use the taps and the resistors for each respective amp. So when you switch up, this is the JTM 45 side. It comes off the 16 ohm tamp through a 27K resistor. When you switch down, it uses the 4 ohm tap with the 56K resistor, or the 6G6 setting. So it's a really material difference. It's about roughly 3 times as much negative feedback for the JTM than it is. So this is really a versatile switch setting. Yeah, obviously this is global, so you can play either half at either setting, which is wonderful. On the back, I did decide to make a change. I actually removed the presence control. I thought it was too subtle. It just wasn't effective enough for me. So what I did was, how earlier in the earlier video I talked about that ground lead that comes over but was unused. So I attached the 4.7K tail resistor to that ground point. So I ended up using that. And of course, this is where the feedback comes in. I've got shielded cable running to the double pole, double throw switch, and then I come into the non-input side of the phase inverter here. So that's working flawlessly. What I did was I actually put a Vox style cut control in the back, and it's much more effective. So this is a analog 250K pot and a 4.7 nanofarad capacitor between the two grids on the power tube, and it works fantastic. So
I really like the late in the circuit ability to adjust treble, and this one has a beautiful range and sweep. The master volume, couldn't be happier. Beautiful range and sweep all throughout the dial. So that was sort of the finishing touches that I decided to change, implementing the respective feedback through the switch, and then putting the tail here and changing this to a Vox cut control. So that's that. Just to review, I think one of my first videos, when I first started assembling this, I had 22 Nan here. You may have seen that. The correct is 100 Nan, and obviously I have replaced that. I've double checked every component on the board, and as it stands, there's only 2 unused eyelets. Everything came out really a little better than I had imagined. On the JTM side, basically I removed all the underboard things that were linking the old AB165 this direction. I talked about in the earlier video this where this joined, and it kind of daisy chained over this way. Anyways, I cleared all that out, and then on the white, blue, and brown tone control connections, I ended up moving them here, here, and here respectively. And then this is where the JTM 45 tone stack connections come in. So that it worked out flawlessly. It's not perfectly straight and aligned, but it came out pretty neat. Very happy with it. So to talk about just the again final review, this is a JTM 45 blues breaker. Every component is 100% according to the original 1961-62 schematic. This is where I elected to put the mid control with a mini mini knob that matches. It's got beautiful sweep and range. And then here's your input, and up on this switch is your bright channel, and it mutes the normal channel, and down is the normal channel, and it mutes the bright channel. This amp is actually on right now and dimed, and it is dead silent. I mean, it is, there is no noise floor. And I attribute that to lead dress, using shielded cable on the areas where there's the greatest chance of any noise coupling, high attention to lead dress. Couldn't be happier. Then on the 6G6 side, it is also 100% to the schematic, with the exception of 4 changes, because the JTM and the 6G6 have to get channels merged, and they had a little bit different gain structure and setting in the phase inverter, which I kind of met in the middle on. Talked about that in an earlier video. So just to go over this, so the only non-stock values are attributable to the way I wanted to mix the channels. So this resistor going up to pins 3 and 8, this is a 680 ohm, and this resistor here is an 8.2K, and then the tail is the stock 4.7K. So the 680 has been changed, the 8.2 has been changed, and then on the input I've got a 10 nanofarad. So those are the 3 changes where I basically met in the middle and did the math and are happy. The last thing that I added, and this was due to channel mixing also, it worked fine, but the way that the 6G6 came in, there's high voltage present here from the plate, and that was coming up to the treble control on the JTM 45. So I added a 22 nanofarad cap off the plate here to block the DC before it comes in to the 470K mixing resistor. So this is the 6G6 side coming in. I added the 22 nan to block the DC, and then this has no DC on it, and then the treble control comes through a 470K mixing resistor. So just in terms of its bone stock, minor changes to the phase inverter values, and then I did add the 22 nanofarad coupling capacitor here to take the DC off for the channel mixing. You got the benefit of the dual feedback settings, the benefit of being able to have both JTM channels on this side. You got the post-phase inverter treble control on the back, Vox style. Of course, you have a master volume now, and then you have Mercury Magnetics output transformer. We've got paralleled outputs, and you have 4, 8, and 16 ohms for great cabinet versatility. I checked it on the scope, putting out right around 48 watts, and it sounds absolutely incredible. Like I said, there really is no noise floor. It's dead silent, and great control sweep on the knobs. I couldn't be happier with the way it turned out. It's a lot of work. I mean, to do this whole project, I've got about 35 hours of work in the amp from start to finish. A few details that some housekeeping and cleaning I did. I cleaned all of the tube sockets. I cleaned and lubricated all of the potentiometers. And then on the power tube sockets, I actually cleaned them with pipe cleaner. Then I tightened up the socket connections on the other side. And then I added new tube grip retainers on both of these because the old ones were shot and really adding no value. And since they hang upside down in the cabinet, I wanted to make sure we didn't have any trouble there. So we got good solid connections on the power tubes. Those were really loose and flimsy, and mechanically they're held in solid now. I think that really covers it. You can study the video, you can look at the implementation and the layout, how I chose to do it. Again, I hope you've enjoyed this video. There's, like I said, there's a few variants of this, but in my opinion, this is absolutely the most functional. And if this is something you would like to do or have done to your Bassman, this is what I do here at Pro Amp Solutions. I specialize in vintage amp restoration, modifications such as this Ness mod project, custom voicing, and of course repairs of tube and solid state amplifiers. And you can visit me at proampsolutions.com. My email address is john@proampsolutions.com. And then I also have a site called Take on Tone. And that's where these videos are going to be produced for educational purposes and to demonstrate a little bit about what we do here at Pro Amp Solutions. We'll be doing Instagram shorts, and thus far all of my advertising has been referral based. So going forward, we'll be active on social media with regular videos and Instagram shorts, and I would appreciate any business that comes my way. And my desire would be to make you a raving fan.